With me. In the previous class, we written a program for arithmetic, relational, logical, and assignment operators. So, in this class, we written a program for unary, bitwise, and ternary operators. So, first one, unary operators. In the unary operators, we have different types: unary, positive, and negative. So, pre-increment, post-increment, pre-decrement, and post-decrement. These are the types of unary operators, right? So, using an unary operators. So, in the unary operators, we have a positive and negative value, unary plus and unary minus, right? So when we use an unary operator, it increment the value by 1. Suppose we write an a plus plus, that means, so plus means positive, it increment the value by 1. So for suppose here we take an a value 4. So if we use an a plus means, so it means 4 plus 1, it increment the value by 1. So 4 plus 1, 5. So in the increment operator, we have two different types. What are those? Pre-increment and post-increment. Suppose symbol of the pre-increment means first it increment the value by 1, then only it prints the value. So pre-increment, this is it. So post-increment means after printing the value, it increment the value by 1. So this is a post-increment. Suppose pre-increment, suppose here a value 4, we use a pre-increment means, so first it increment the value by 1, 4 plus 1, 5. So post means after posting the value, so first post the value, print the value 4, then it increment the value by 1, 4 plus 1, 5. After that it prints. So these are the pre-increment and post-increment. In the same way, we have a decrement also. So pre-decrement and post-decrement. So we write in a program. So we use same value a equals to 4. So here system dot out dot println. So using an unary operator system dot println. Here we write. So using an unary operators, right? So first one is pre-increment. So pre-increment means it increment the value by 1. So using an pre-increment operator. So pre-increment operators, a value is, so here we use plus a pre-increment, right? Right, this is a pre-increment. So what is our a value? 4. So 4 plus 1, we get an output here 5. This is the pre-increment operator. So using a pre-increment operator, a value is 3. Okay. So assignment operators, after modulo division operator, a value is 0, right? So we get here we take in a reminder. So Java application, right? A value 1, because here after the modulo division, a value is 0. So here 0 plus 1 pre-increment. So it in 0 plus 1 means the value a value is 1, right? The next one is post increment. So suppose here a value is right. Then using a post increment. Post increment operator, A value is post increment. After printing the value, so it increment the value by 1. So right click, run as Java application. Right. So here using a post increment operator, a value is 1. So after the printing the value, it increment the value by 1. Suppose if we print a value here, so a value is plus a. So after printing the value, it increment the value by 1. So 1 plus 1, 2. Here a value we get 2. Right? So a value is 2. So post means after printing the value, it increment the value by 1. That is a post increment. Pre-increment means first it increment the value by 1, then only it prints. These are the difference, pre-increment and post increment. In the same way, decrement and pre-decrement and post decrement. So using a post decrement operator. So decrement means minus operator. A value is, so post, so first we write pre-decrement. So pre-decrement means after decreasing the value by 1, it prints. Here a value 2. So pre-decrement means after decrement. So 2 minus 1, we get an output here 1. So a minus minus a. This is a pre-decrement, right? So right. So using a pre-decrement operator, a value is 1. That means 2 minus 1. Suppose using, so this is a pre-decrement. Suppose we use a post decrement. That means a plus plus. So first here a value 2. Instead of pre-decrement, we use post decrement. That means a minus minus. That means after printing the value. That means we get an output here 2 only. So after printing the value, it decrement the value by 1, right? Using a post decrement operator. Here a value 2. So post decrement means after posting the value, it decrement the value by 1. So first it prints the 2. Then it 2 minus 1, we get an output here 1. Using, suppose if we print an a value. So a value is, so 2 minus 1, we get an output here 1. It is in a post decrement. So after printing the value, it increment the value by 1. So a value is 1. First a value 2. We use in a post decrement. Post decrement means first it print the value, then it decrement the value by 1. So 2. 2 minus 1. So that means 1. The a value is 1. So pre-decrement means it decrement after the post. Suppose if you use here system.out.println using pre-decrement operators, a value is, so 1 minus 1. The a value here 0. Right? So using a pre-decrement after a value is 0. 1 minus 1. So pre-increment means it increment the value by 1, then only it prints. So post-decrement means after printing the value, it decrement the value by 1. That is the difference between pre and post. Pre means first increment, post means after printing the value, it increment. So in the unary operators, pre-increment, post-increment, pre-decrement, post-decrement. These are the types of unary operators, right? The next one is bitwise operators. In the bitwise operators, we have a different types: bitwise and, bitwise or, bitwise XOR, bitwise not, left shift and right shift. Those are the types of bitwise operators. So in the bitwise operator, suppose we take here a value as 4. So it converts into a binary format like 1. Suppose we take 4. So 4 binary number like 1100, 20011. So those are the numbers of binary numbers of 4 and 2. So, what is the condition of bitwise AND operator? So bitwise AND operator, in the both value having a 1 in the same place, then the result is 1, otherwise 0. Suppose A1100. So we already discussed those topics in the previous class. Once check for that. So using a bitwise operators, right? First using bitwise and and operator. So we use same 4 and 2 value here. Suppose here we initialize int c equals to 4, int d equals to 3. So int r, int f. So we already used here c and d value. That's why we're using a different values here, r and f. So we use these two values for bitwise operators. So first one, bitwise and. So what is the condition of bitwise and? It converts in a binary. So suppose 4 value 1100, then 3 binary 1001. Suppose randomly I selected. So what is the condition of bitwise and? Both value having a 1 in the same place, then only the result is 1, otherwise it's 0. Suppose in the first place 1, in the first place 1, both places in the same value, so we get an output here 1. The next one 10 means same place different value, 0 means 0 means same place, so same place same value. So first place 1, first place 1, so we get the value 1, otherwise the result is 0. So 100. Suppose it is the binary number for 4 or 5. So we get an output here 5. So it converts the numbers into a binary format. Then it checks. So condition of bitwise AND means both value having a 1 in the same place. Then the result is 1. Otherwise the result is 0. So using a bitwise AND operator, here we write in a condition. So what is the condition? So we use R and F, right? So R and only one F, right? So right click, run as Java application, right? So using a bitwise AND operator, get a 0. So here using a bitwise operators, right? The next one is bitwise OR operator. Bitwise OR means if at least one value has a 1, the result is 0. So in bitwise OR operator, right? So same 1100 1001. That means, so bitwise AND means at least one One value has 1, the result is 0. Suppose here 1 1 1. So 1 0 means at least 1. So first 1, right? We get an output 1. 0 0 means 0. 0 1 means 1. At least one value, the result is 1. So 1 1 0 0 1. So this is our output 1 1 0 1. Suppose the binary number, the number 4 or 5. So we get an output here, those value. So this is a condition of bitwise OR. So at least one value as in a 1, the result is 1, otherwise 0. So this is a condition for bitwise OR. Bitwise AND means in the same place, same value. Then only the result is 1, otherwise the result is 0. So right click, run as Java application. Right? So using a bitwise OR operator, we get an output 7. So then bitwise OR. Then bitwise XOR. XOR means only one value as in a 1, result is 0. Both are same. Suppose here at least one value. 1 1 means, so what is the condition of bitwise XOR means? So at least only one value as in a 1, result is 1. If both places same value, the result is 0. So first place 1 here, first place 1. So same places have same value. That means both places same value, the result is 0. At least 1 1 0. So at least we have only 1, right? 1 1 0 0 means we get an output 0. 0 1 means 1. So this is the condition of bitwise XOR. So both places have the same value, the result is 0. At least one value as in a 1, the result is 1, otherwise 0. Both places have same value, the result is 0. At least one value as in a 1, the result is 1. This is a condition of bitwise XOR. Right? So bitwise AND means same place having a same value, the result is 1, otherwise 0. So bitwise OR means at least one value as in a 1, result is 1. Bitwise XOR means if the same places having a same value, both places having a same value, the result is 0, otherwise 1. So condition of XOR, right? So using a bitwise XOR operator. So XOR operator. So symbol of the bitwise XOR is cap symbol. So right click, run as Java application. Right, using a bitwise XOR operator 7. Then left shift and right bitwise not operator. That means it flips every bit. Suppose here 1 1. 1 becomes 0, 0 becomes 1. So for suppose 4 binary value 1 1 0 0. The first 1. So 1 becomes 0, 0 becomes 1. Then the result it prints. So using a bitwise not operator. So symbol of the bitwise not operator is so right click, run as Java application. Right? So -5. Right? This is a bitwise not operator. The next one left shift and right shift. So left shift means it adds 0 to the right and multiply by 2. So bitwise left shift operators. Here left shift symbol double less than 1. This is left shift. And the next one is right shift means so it removes the bits from the right side and divided by 2. In the left shift it adds the zeros to the right side and multiply by 2. So left shift. In the right shift it removes the bits from the right side and divided by 2. So left shift multiply by 2, right shift divide by 2. So in the left shift it adds a 0 to the right side and in the right shift it removes the bits from the right side. So that is the difference between left shift and right shift. So right shift operators. So right. So right click, run as Java application. Right. So let's click operator. We can also create right shift operator too. So these are the bitwise operators. So unary, bitwise, then the last one is ternary operator. What is a ternary operator? So it is a shortcut to write an if else in a single line. So ternary means it uses three parts like condition. So what is the syntax of ternary operator? Condition, value is true, colon, value is false. Right? Instead of writing an if else statement, we write a ternary operator using a one line like three parts. That is a ternary operator. So we write in a format line for that. So using a ternary operators. So we use same for R and F for A and B values. So Part means, so it flips every bit. That means 1 becomes 0, 0 becomes 1. Left shift means it adds 0 to the right one and it divided by 2. Multiply by 2. So right shift means it removes the bits from the right side